So today we're going to be talking about measurements and chemical calculations. So and your homework assignment is already up. You guys can already get started on it if you haven't already done so. Okay, so as scientists, and as a scientist, I can vouch for science. So as a scientist, we like being a little lazy, right? So we try to find shortcuts to just about everything. Scientific notation is one of those shortcuts. Yes. Yes, I probably do. And so the way that we would do scientific notation is we have a single digit, decimal, and then, let's see. Is that better? Single digit, decimal, and then followed by the digits that would be following it. And then we multiply times 10 to the exponent. And what do I mean by that? So as a scientist, we often will have to work with very, very small numbers or very, very large numbers. Like for instance, if we had like 0.00000000025, right? It sucks to sit there and write all of those zeros. 0.00000000025, right? So that takes a lot of time. I don't have a lot of time to be writing all those zeros. I need to find time to sit there and figure out a way of writing it very, very fast, right? So if we had that number, zero point zero 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 25, it would be a pain to sit there and write that over and over again. So we basically come up with a way of doing that, and that's called scientific notation. Okay. Now the way that we would change this into scientific notation is we start at that decimal, and move the decimal back 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces, so that we have that first non-zero digit before the decimal. Then we put that decimal, and then we put the numbers that will be following that. If it's just one number, then we don't have to put that one number that's following it. If it's 5 numbers, then we'd have to put 5 numbers that would be following. And then we went over 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. So since we went over 9 spaces, we'd put -9. Now that minus lets us know that our number is a very, 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 very small number. Okay. You guys good? Pretty simple, not too hard. Okay. So now this works also when we have very large numbers. Okay. So if we want to change this to scientific notation, we'd start here. 1, 2, 3, 4, 5, 6, 7, 8. So then it would be 2.5 times 10 to the 8. Okay. Now it's a positive number, so we know that that number is going to be a pretty large number. Yes, sir. Yes. And that's essentially what we've done here, right? Okay. Yeah. Okay. So you guys get that pretty simple, not too hard. Okay, so let's test your skills. So convert 3,672,199 to scientific notation. Now you guys know that I gave you guys this 2 weeks ago, the lecture notes 2 weeks ago. Okay, good. Just making sure. Or you guys at Harnell, you guys got it last week. So. Okay. Now, you guys that are online, you guys know that you guys can write on my screen. So the way that you would do that is that it says, you'll see viewing Dr. Henry's screen, right? There's a big green tab. You want to click on that. And then what'll pop up is you'll have a 3 dots, or you'll see more, one or the other. You click on that. And if you click on that, you'll see the word annotate. If you select annotate, then you will get a menu that'll say mouse, select, text, draw, stamp. And then you guys, if you select draw and use the squiggly line, then you'll be able to write on my board. Okay. So if you guys can do that at those who are online, if you guys can do that.
Wait, how do you write on your board again? Like for online?
If you go to, you see at the very top, there'll be a green little tab that says you're viewing Dr. Henry's screen. You want to click on that, and then a menu will pop up. When that menu pops up, there'll be one point that says more, or 3 dots, or it'll say options. You'll click there. When you click there, there should be another word that says annotate. So there's a question. Would it work if the negative number would be moving? So would it work if the negative number would be moving the decimal to the left? So yeah, so the negative number would be moving the decimal. A negative number is moving the decimal to the right. So, and then a positive number would be moving the decimal to the left. Yeah, so in this case, right? This is my left, right? Making sure. Left, right? So if we take a look at this number here, so then 1, 2, 3, 4, 5, 6, right? So then that's moving it to the left. Is that correct? So then our decimal would be 3 point, in this case, 67219 times 10 to the 6. So it has a positive value. right? Where if we're moving the decimal to the right, down here, it's 1, 2, 3. So then the answer would be you guys can talk, right? Got your tongue? $4.61 times 10 to the negative 3. Okay, then that way it has a negative value, right? Okay. I know my head's big, you know. I told you guys I look pretty, you know, so you have to have a big head to go with it, right? So. Okay. Piece of cake, not too hard. Okay, so let's move forward. Okay, so now we have to be able to swing both ways, right? We need to be able to go to decimal form, and we need to be able to go to scientific notation. So we want to be able to swing both ways. So in that case, I want you guys to change this into decimal form, these two problems. So we have convert 3.49 times 10 to the negative 11 to decimal form. And convert 5.16 times 10 to the fourth to decimal form. Okay. I love that. Proactive. Let's see, so that's okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then so 51,000 here, 51,600. Piece of cake. Everybody agree? Anybody disagree? Good. See, I love it. I love when I just get to sit up here and look pretty, you know? Okay. So you need to be able to do this on your calculator. How many of you guys have a calculator with you today? Good. How many of you guys have your cell phone with you today? Good. So if you guys have an iPhone or a whatever phone, you all have calculators, right? So pull out your calculators. So what I'd like you guys to do is, I would like you guys to enter this into your calculator. Now, the key is that we want to talk about the exponent. There is a button that is dedicated to the exponent on most calculators. So if you guys have the iPhone, let's see. If you guys put it this way, it's just a standard little calculator. But if you turn it to the side, you have a scientific calculator. Okay. So if you put it this way, standard calculator, turn it to the side, scientific calculator. Okay. Okay. So there is a button on your iPhone and on most calculators that either says EE or it'll say EXP. Now, this stands for your exponent, right? So that's 10 to the whatever power, right? So when we're trying to enter our number into the calculator, we're going to type in, let's say we're doing 3.4. So 3.49. Then we will press the EE button or the EXP button. Okay, now this has a negative value, right? You don't want to use the minus sign. What you want to use, there's a button that has plus, minus, or it'll have minus in parentheses. So it'll be one of those two buttons on your calculator. Okay, so you want to use that button, and then you want to press 11. Okay. Did everybody do that? Okay, so if you go ahead and do that on your iPhone or on your calculator, if your calculator is set up for decimal mode, then it'll change it to a decimal, right? If your calculator is set up for scientific mode, it will leave it into scientific notation. Okay, did everybody get it? Yes, no, maybe? Now, you guys are saying, oh God, I know how to use a calculator, right? You're like, 9 times out of 10, most people make a huge mistake on their exam by entering stuff in their calculator, right? They understand the concept, they understand what they're supposed to do, but when they enter it in the calculator, they screw it up. Okay? Questions, concerns, Cash? If you have any questions, there is a link under Canvas. I'll make sure that you guys know where it's at. I believe it's under resources that has how to use your calculator. I have Texas Instruments, and I also have Casio's listed up there. Okay. Okay, so now we get to talk about quantity. So I need you guys to give me 5. I need you to give me 5. Okay, yeah, just that'll be fine. I'll accept that. I won't argue. Yeah. You're saying 5 fingers? I don't want 5 fingers, right? So I just told you I needed 5. 5 of what, right? That's the point. He's giving me 5 fingers. He giving me $5. He's giving me $5 million, right? Isn't that right? Good, good. I just want to make sure that I'm getting that $5 million still, right? Okay, so it's important for us to use units. When we talk about a quantity, quantity has to be a combination of a value, 5, and units. Now, Jason's over here saying, oh my gosh, everybody knows that, right? Boy, you'd be surprised, right? How many people don't use units? So you'll tell me, Dr. Henry, I need 5. 5 of what? 5 underwear, 5 girlfriends, 5 husbands. What do you need, right? 5 of what? If you don't tell me, I can't help you. I need to know those units. When we're working with chemistry, it is important. It is very valuable that you put the unit. Are you talking about 5 atoms? Are you talking about 5 molecules? Are you talking about 5 milligrams? So we need to know what units we're talking about, okay? So, example, express 50. If I just told you 50, you'll be say 50 of what? But if I say express 50 minutes in seconds, then I know exactly what I need to do, right? So, how many seconds are in a minute? So we know that for every 60 seconds, that's going to equal 1 minute. Now, this is an equivalency or a conversion. It'll allow us to convert from minutes to seconds. And so we're going to use this. Our given here is 50 minutes. That's what we're starting out with. And we want to change it to seconds. So I set up this nice little table, 50 minutes, and I'm converting it to seconds. So I want seconds. Seconds is what I want. Okay, so if I want to get rid of minutes, we kind of talked about this yesterday, or not yesterday, last week, right? So if I have x over x, it cancels out, right? So if I have minutes over minutes, it's going to cancel out. So in this case, I'm going to put the minutes where? On top or on bottom? And I'm going to put my 60 seconds on top. Okay. Questions? So my minutes cancel out, and I'm left with just seconds. Now, this process is called dimensional analysis. The benefit of following your units or following your dimensions is it'll let you know if your answer is going to be right. Because if you flipped it, you'd end up with minutes squared over seconds, which is exactly what we don't want, right? Okay. Okay, so now let's give you guys a run at it. The oldest horse track in the United States is the 8-furlong Pleasantation Fairgrounds racetrack in California. What is the length of the track in rods? 0.025 furlong is equal to 1 rod.
Point two. Two.
Okay, what's my given? Okay, so we have 8 furlong. So what is my equivalency? So we have 1 rod on top. And you said 0.025. And that's going to equal furlongs. Ran out of room. Okay, question, concerns, Cash?
Wait, how'd you get that
Okay,
again?
I'm still waiting for it to come up here. What was that, Jason?
How'd you get that again? 320?
You got to say it one more time. You have to say it a little bit louder.
How did you get the 320?
So what we did was we have 8 divided by 0.025.
Okay.
So the numbers on top, we multiply across. So that's 8 times 1. And then the numbers on the bottom, that will be division by, dividing by.
So it's 8 times 1 rod right across and then divided by
Yes.
0.025.
What was that?
You just pretty much multiplied across and then divided the zero.
Yes, that is correct. I have 2 questions going on. So now your question is, I'm sorry. Oh, sorry, 320 rods. My bad.
Oh, okay.
Yes, it's not furlongs, it's rods, because the rods. See, and that's the reason why we cancel it out, so that we don't make mistakes like that. See, I planned it on purpose. Good eye, good eye. Okay, questions? No other questions? Let's move on. Okay, so we've already talked about equivalencies and conversion factors. All right. So you guys are feeling comfortable? You got it? Yeah, no, maybe. You guys look like zombies. You would act like it's Monday. It's not Monday, it's Tuesday. I know it's Tuesday today, because yesterday was a really messed up Monday, let me tell you. Okay, so I want you guys to write these into equivalencies, right? So what do I mean by that? So I want you to say they're equal to, or this over that, or, okay? So 1 day is 24 hours. Give me some of your equivalencies. Okay. 1 day equals 24 hours. What else? 24 hours equals 1 day. Is there any other way I can write this? Can I say 24 hours over 1 day?
Yep.
And can I say 1 day over 24 hours?
Yeah.
Okay, so another one. My car averages 17 miles per gallon. $17 miles over 1 gallon. And just flip it, 1 gallon over 17 miles. And then we could do all of the equals. Okay. Piece of cake, not too hard. I'm like, God, I thought you said chemistry was hard, right? Don't worry, we'll make it that way. Okay, so this is just the algorithm that we go through to solve a problem, right? I like to do it very simple, right? You guys can read through the algorithm. I'm going to tell you exactly the same thing. I always like to start off with what I'm given with. So here, what is my given? Okay, so we have 672 hours. What is it that I want? I want weeks, right? So what are some of the equivalencies that we know? There's 7 days in a week. There's 24 hours in a day. So how would I use those equivalencies? I'm starting out with hours. How can I get rid of hours? Okay, so who's going to be on top? Who's going to be on bottom? Okay, so 24 hours on the bottom. So then the hours are going to cancel out. And we have 1 day on top. Okay, so that gives me days now. Is that what I want? I want weeks. So how do I get to weeks? Okay, tell me how. Who's going to be on top? Who's going to be on bottom? Well, we already got rid of hours right here, right? So now we're days, right? So we want to put days on the bottom. So how many days? 7. And that's 1 week on top.
Days cancel out.
Okay, so days are going to cancel out. And we're left with just weeks. Okay, so what do you guys get? Piece of cake? Okay, so that's just dimensional analysis, right? Are you sleeping on me again? Okay, I'm just making sure.
What'd you divide to get the 4 weeks?
What was that?
What did you divide to get the 4 weeks?
So we started out with 672,
Mm-hmm.
and then we multiply that by 1, and multiply that by 1, and then we divide that by 24, and then we divide that by 7.
Okay.
Can we do it across, like 672 times 1 times 1 divided by 24 times 7?
Yep. So yes, what's on top, we'd go straight across, and then what's on bottom would go straight across, and then you get those numbers and just divide it by that whole number at the end. That'd be another way of doing it. Okay, are you guys with me? Good. Thumbs up to let me know. With good questions. Keep asking. Okay. Okay. Ready to move forward? What is the distance expressed in miles? I say, what distance expressed in miles with an automobile travel in 3 hours at an average speed of 62 miles per hour? Okay, what's my given? Okay, so 3 hours is my given. What's my equivalency? 62 miles per hour. Okay, so how am I going to use that equivalency? Miles on top, 1 hour below. Hours cancel out. Okay, questions? Okay, a little girl broke her piggy bank. Inside, she found 2,608 pennies. How many dollars does she have? Okay, so you said $1 is going to equal how much? 100 pennies? Okay, so my given is? And the units for that? So how am I going to use that $1? Bless you. Pennies cancel out, and we're left with just dollars. Cash money. Okay. We don't have to do that since we're in the US. Okay. Now we get to talk about the metric system. So I kind of mentioned this a little bit last week. We talked about SI units. SI units are basically the units that everybody in the world is going to be using, particularly in science. So we want to make sure that everybody uses some type of standardized unit system. However, we are in the US. We don't like the metric system. We like the empirical system. We like to be, under that king's foot, right? And the length of his finger, that inch, right? So, but in this class, since it is a science class, we are going to be using SI units. We're going to have to be able to go from the imperial system to the metric system, okay? So you want to be familiar with it. Now, the beauty of the metric system is, okay, well, first off, let me get started here. Let me get on my soapbox just a little bit. Okay, so and I want you guys to think about this. So how many inches are in a foot? How many feet are in a yard? How many yards are in a mile? Did you say 12? No, it's not 12. It's a lot more than 12. So did anybody know off the top of their head? Oh, it's not 400. No. 672. Didn't you guys know that? It makes sense, right? Doesn't it? It's all perfect. Don't they? Right? No. So the thing is that it's not perfect, right? We went from 12 inches to 1 foot, 3 feet. Does that make sense? I mean, there's no rhyme or rhythm to it, right? Where the metric system has multiples of 10, right? So we use the metric system because, like I said, scientists are lazy, right? I mean, although we like calculations and everything, but we don't want to do crazy calculations. 672, come on now, really? Right? So we want to try to find ways to make our lives a lot easier. Multiples of 10, everybody can use multiples of 10, right? It's not that hard, right? Yeah, no? Okay, so that's one of the reasons why we use the metric system. That's one of the reasons why we try to use the metric system here in science. Now we're going to blow that up when we start talking about temperature, just so you guys know. Okay, so you guys need to be familiar with the metric system. You need to be able to use it. Can you get a tissue? Yes, you can get a tissue. I believe there's one. Yeah. Okay. So in the metric system, the number is going to be dictated by the prefix that is going to be used. So we always have a base unit. So like, for instance, if we're talking about mass, we're going to be using grams, right? And then we use a prefix to let us know how big things are, right? Okay. So these are the prefixes. This here represents our base unit. So we're talking about mass, grams. If we're talking about distance or length, we're talking about meters. If we're talking about volume, space occupied, we're talking about liters. So decagram. That means 10 grams will equal 1 decagram. Yes. A 100 grams will equal 1 hectogram. 1,000 grams will equal 1 kilogram. 1,000,000 grams will equal 1 megagram. 10 to the 9th grams will equal 1 gigagram. Which is a billion. Yes, sir. Can you repeat that, please? I'm sorry. It doesn't actually, because it's based upon a year, right? So, yeah. Okay, and a trillion, or 10 to the 12th, is going to equal grams, is going to equal a teragram. Okay. Now going the other way, 10 decigrams will equal 1 gram. 100 centigrams will equal 1 gram. 1,000 milligrams will equal 1 gram. 10 to the 6 micrograms will equal 1 gram. And 10 to the 9th nanograms will equal 1 gram. And 10 to the 12th grams will equal, picograms will equal 1 gram. I'm going to add one more. Centum. And that's going to be 10 to the minus 15. So that means, I ran out of room again. Was that? It's an M. Sorry, my 3rd grade writing. I'm having trouble with my humps there. There you go. I also forgot that I wanted you to get my mouse. It's easier for me. Femto. 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 15. Yes, that's a 15. Okay, again, my 3rd grade writing. Okay. Okay, so some other things that I want you guys to keep in mind. Mass. So mass is going to be a quantity of matter, right? So we can measure mass, okay? Now weight is going to be dependent on gravity. So mass and weight are different. So I weigh 220 pounds. Okay. So if I go on to Mars, am I going to weigh the same? Okay. So then will I weigh the same? Because weight is dependent on gravity. Okay. So my mass is 100 kilograms. So if I go to the moon, is my mass going to be the same? Those who say yes, raise your hand. Those who say no, raise your hand. Okay, the correct answer is yes, it will be the same because mass is not dependent on gravity. Okay, you guys got that? Simple concept, right? Weight dependent on gravity. But my mass will be exactly the same. Okay. So when we talk about SI units for mass are going to be kilograms. However, in chemistry, we will often adjust our units appropriate to what we're using. So if I'm working with something that's pretty large, I may use a kilogram. But if I'm working with something that's pretty small, I may use a microgram. Okay? So, but it will still be in grams. Yes, that is correct. Yeah. Okay, so when we talk about length, we're going to be using meters. Meters. Okay, meters. So again, if we're working with smaller distances, we're going to be using centimeters or millimeters or micrometers. Okay. Okay, so 1 kilogram is going to equal about 2.2 pounds. So how many of you guys use tender? Tender. Oh, nobody wants to admit it. Okay. Now, when I see all you guys on there, oh. Okay. Okay. So now this is that point about using units, right? So if I go on to Tinder and I say I'm a man and I weigh 100, right? Right? I do weigh 100. I weigh 100 kilograms, right? But you would say what? I heard her. Come on, speak up. What would you say if you saw a guy weighing 100? Damn, he's little. 5'8", 100 pounds, right? That's the first thing you're thinking is pounds, right? So this is why units become important, right? Because if you don't put those units, they're thinking you're little. I mean, all the girls are sitting there laughing. God, he's so little, right? And then you see this big guy, and you're like, oh, wait a minute. He must have not meant pounds, right? He must have meant pounds, not kilograms, right? So. Okay, so we want to make sure that we're using those units, right? Okay. So 1 inch is equal to 2.54 centimeters. We learned that last week when we were doing all those calculations online, and you guys were like, damn, I can't get this to work, right? Got a mouse? No, go get a mouse. They're cheap. Well, I don't know about now. They were cheap. Yeah. Okay, so for the units of volume, we're going to be using cubic centimeters. SI units, I'm sorry, cubic meters. SI units is cubic meters. Now, but we often will use milliliters or liters, right? So have you guys heard of cc's, right? I need 5 cc stat. What is a cc? It stands for cubic centimeters, right? So 1 cubic centimeter, or we'll say 1 cc, is equal to 1 milliliter. Okay. Now we know that when we talk about volume, volume just represents the space that's occupied. Okay. So we often will think of it when we talk about a cubic centimeter, cube, right? We think about a cube, space occupied. And that's what we're initially started from. Now, but we apply volume to, liquids, all types of liquids, right? Okay. So this is just basically showing us that. So 1 milliliter is going to equal to 0.001 liters, which is going to equal 1 cubic centimeter. So we can use that to make equivalencies. The fact that we have that metric system. So we know that any unit that we're using, 1,000 of those units is going to be equal to 1 kilo unit. So whether it's mass, or we're using grams, or whether it's liters, right? We always know that kilo stands for 1,000. There's going to be 1,000 of that base unit to equal 1 kilo. That's the same thing with centimeter, right? So 100 centimeters are always going to equal 1 meter. So 100, whatever unit, centigram, centimeter, centiliter, will always equal 1 of that unit. Same thing with mil. Mil in Spanish means mil. It means 1,000, right? Okay, so we know that 1,000 milliliters will equal 1 liter. Mil. Okay. Okay. How many grams are in 0.711 kilograms? Okay, what's my given? and units. And what do we want? So kilograms are going to cancel out.
7-Eleven.
Right, 7-Eleven. Reminds me, I want a slushie. Yep. Okay. Piece of cake. Ready to move forward? Okay. Convert 5.25 times 10 to the 5th milligrams to kilograms. Yes. Yeah. Okay, what's my given? $5.25 milligrams. And what is it that I want? mg is the abbreviation for milligrams. I want what? Kilograms. So I want kg. Okay, so how can I get there? So you said 1 gram over 1,000 milligrams. Okay, so milligrams are going to cancel out. That's a G. So then that gives me grams. So how do I go from from grams to kilograms? So you're saying one kilogram over 1,000 grams. So that equals 0.525 kilograms. Okay, questions? Concerns? Cash? Kool-Aid? I want money. I don't need affection. Okay, let's move forward. Okay, a fruit drink is sold in bottles that contain 1,892 milliliters. Express the volume in cubic centimeters and in liters. You got it? Okay. You can help me out then. What's my given? Okay. 1,892 milliliters. Okay. So how can I change that to cc's? What is the equivalency for milliliters to cc's? It's going to be the same thing. It's 1 to 1, right? 1 milliliter is going to equal 1 cc, cubic centimeter. So then we're just going to hit with the same number, just different units. Okay, what about liters? Okay, said 1 liter over 1,000 milliliters. Man, those multiples of 10, so beautiful, aren't they? Okay. Okay, so let's go ahead and get started. Back up. Okay, sig figs, significant figures. Sig figs, most students love this topic. It's the favorite topic of everyone. So let me kind of tell you what sig figs are for, and then I'll try to explain it to you in a little more detail, okay, by examples. Okay, so sig figs are dealing with accuracy, how accurate things are, right? The fact is that when we may take measurements, depending on the type of instrument that we're using, we may not be that accurate. We may be way off. We may have uncertainty associated with it. Let's say the equipment here is different than the equipment at Harnell, right? Our equipment here in Coalinga is old. Harnell's equipment is new, brand new. So their equipment is probably more accurate than our equipment. And so if we were sharing data, right, we're looking at samples, they're looking at samples, we won't be as accurate as they are. So we have a lot more uncertainty associated with our data in Coalinga compared to that of Harnell. Okay. So are you guys kind of getting what I'm talking about? Okay. So let's say, for instance, let's say we had a scale, just a regular standard scale that we weigh people with, right? So in Coalinga, the scale says that I weigh 200 pounds. Okay. We'll get to there. Just hold your horses. We'll get there. I promise. Okay. So in Coalinga, the scale says I weigh 200 pounds. But when we go to Harnell, the scale says that I weigh 220 pounds. Right? So there's uncertainty associated with the scale in Coalinga. Right? So when we're talking about sig figs, significant figures, when there's uncertainty, we put zeros there, right? So in other words, the only thing that Coalinga scale is sure of is that it's 200. It's 200 and something, right? But we don't know if it's 230, 220, 210, right? 205, right? Or, well, it would be closer to 300 in that case, but we'll get there. Okay, so now Harnell scale, it says 220. So that has two significant figures. 1, 2. That 0 isn't acting as significant. Okay, so the first one, 1 significant figure. The second one, 2 significant figures. Okay, now that doesn't mean that it's still not 220, right? It's still 220, but there's only 2 significant figures. This 0 is only acting as a placeholder. We're not sure about it. We're not 100% sure what that 0 is. Same case here. This zeros are acting as placeholders to let us know that it's 200 and not 2, right? So, but we have a lot more uncertainty associated with the top number. Okay, are you guys with me so far? Okay, so let's test this out. So if I have 2, 0, 0, 0, how many significant figures do I have? I have one significant figure. Okay, now it's 2000, right? So we know that those zeros have to be there as placeholders. Now, this is the biggest mistake that students make, right? Because I will say, write an answer, and they'll get an answer like 2000, like I owe you $2,000, right? And then they'll put 2. Is 2 and 2000 the same thing? So if I owed you $2,000 and I paid you $2, I'm like, oh, here you go. Would you be happy? No, you'd be upset. You'd be like cussing me and I'm going to sue you because you're ripping me off, right? Okay, so you don't want to mistake the number, the value of the number for when we're talking about the fix. Okay, you guys understand that, the distinction. Okay, so when we have a number that, a zero that is captive, captive means that it's stuck between two numbers, two non-zero numbers, right? All of those numbers are going to be considered significant, even the zero. So in this case, 202, we have 3 significant figures. Okay? Have that look. Yes. If it was 2100, it would be 2 sig figs. Yes. That's right. So if it's captive, it becomes significant. Okay? Everybody got that so far? Okay. I said, well, he asked, because this is captive, meaning it's between two non-zero numbers, it becomes, so in this case, we have 3 significant figures. 1, 2, 3, all 3 are significant. Okay? Okay, so let's make it a little bit harder, right? So what happens when we do something like this? Let's see. Erase some of this. Okay, so as soon as we put that decimal point, we're telling you, because remember, I'm lazy, right? I took extra effort to put a decimal point and another 0. I'm telling you that that's significant. That 0 after that decimal point is significant because I took that extra effort to let you know. Because otherwise, I could have just wrote as 200, right? I'm not going to put any extra effort in there unless I want you to know it's important, right? And that means that we have 4 significant figures in this case. Okay? Because we took that extra effort to put the decimal there, it becomes, the zeros following that would become significant. Does that make sense? Okay. So, yes, there's 4 significant figures. So if I have how many sig figs do I have now? 6. Okay, you guys seem to get the hang of this. Now let's see if we can throw some curveballs here. So these are called leading zeros. Leading zeros aren't significant. So how many sig figs do I have here? Okay. How about this number? right? 5. Okay. So you guys are feeling confident? Okay, first off, let's start off by filling the mask. Okay, now tell me why you're not feeling confident. Ask a question. You don't get it? Okay, so anytime that you see a decimal, so here we have this nice little decimal here, right? And then that means that these are called leading zeros. They're not going to be significant, right? We're not going to count those as significant figures. But anything that trails this number is going to be significant. Yes. This would become significant. These two, because we have that decimal there, right? Okay. So the decimal kind of lets us know that, hey, we have to take the numbers that are going to be following that number as being important. Here, we have a decimal here. These are lagging zeros, right? But this is after that decimal. That lets me know that I took that extra time to write it, so it has to be important. Okay? So that makes it a significant. Okay? Okay. So let's see. Okay, so let's try one more and then we'll move forward. Actually, we'll do 2 more. Okay. That's a comma. Okay, yes. First number. Sure. Are you willing to bet money on? Okay, how much money are you willing to bet? $1? Okay, I got $1. Anybody else want to get into this action? Oh, you changed your answer now. Are you sure it's 3? Oh, okay. Well, I'm not willing to bet anymore. So. Okay, so how many sig figs? Everybody agree? 3? 3 sig figs? Okay. Now, what about the second? Gonna help us out? You said 6? Are you sure? Well, put money on it? Three. So why is it 3? Why is it not 6? Because it's 2, 0, 2, 0, 0, 0. No decimal point. 202. Yes, it's 202, comma, 0, 0, 0. So why is it 3, not 6? The lagging zeros aren't going to count in this case because we don't have a decimal there. And there's a captive 0. So the captive 0 does count, right? So I should say count. But in terms of significance, let's see, different color. So these 3 are going to be your significant figures, right? These zeros are all uncertain. So we don't know if they're sure. We're not sure. Okay, so we're not sure if that 0 is really a 0 after the 2. It could be 1, it could be, and so we just put 0 there to kind of say we're not sure. Okay, yes, sir. Okay, so repeat that one more time. Uh-huh.
If we
That's
had
right.
a second or third, and lagging zero.
Well, it's only because these count because of the decimal. Once that decimal comes into play, then those lagging zeros will count. So if I had, for instance, if I had 202, comma 0, 0, 0, and I took the time to put that decimal there, right? Then all of those zeros are going to count because that decimal is there. Okay, by me putting that extra effort in putting that decimal, that says, okay, I'm letting you know I'm sure about this number, right? I'm not questioning. Okay, does that make sense? That's right. So yeah, especially if the numbers, numbers that are in front of the decimal. Yeah. Okay. Now, when we talk about exact numbers are exact. So there's no uncertainty associated with it, right? So there's not that uncertainty that's going to be associated with it. So if somebody tells you you have exactly 10, then they're letting you know you have 10. It's exact. So you have no uncertainty associated with it. Okay. And if we're talking about scientific notation, let's say we have this number. Let's see. So if we put in scientific notation, how many sig figs are we going to have? What do you guys think? 3. We only look at this number for sig figs, not the exponent. Okay. How you feeling so far? Tired? You got to wake up. Because we got 2 more hours of fun. Okay, so this is just basically showing you that. So in the very first case, these guys, these leading zeros, they're not going to be significant. Only the numbers, the non-zero numbers are going to be significant. Here, non-zero numbers are going to be significant. These leading zeros are not going to be significant. These are lagging zeros. In this case, since there's not a decimal, those lagging zeros are not significant. So this guy only has 4 sig figs. This 5, because these lagging zeros are not significant. These are captive zeros. They're stuck in the middle. So they become significant. Okay? Questions? Concerns? Cash? I almost got some. Well, it's good. You guys all have Cash App or Venmo, so I know I can get money from you now. So. Okay, now when we're doing addition and subtraction, we have to take in consideration things, right? So we're getting data, we're collecting data from different places. We have to pay attention to each of those data points to find out how significant our number is going to be, right? And then to make the adjustment for the uncertainty that's associated with that number. So the way that we would do this is you want to find the point where significant ends, and we're going to draw a line between it. Okay, so like for instance, where does significant stops in that very first number? After which number? After the second 2. Okay, so I'm going to draw a line there. What about the second number? Same spot. Okay, what about the third number? After the 2. Okay, and the last number, 10, after the 1, right? Same spot. So we have 2 spots to choose from, right? So what you're going to do is you're going to go to the point that is the furthest to the left, right? And that's going to be our deciding point. So the blue line is going to be our deciding point. Anybody colorblind? Just in case, because I always have somebody that tells me later on, Dr. Henry, I really am colorblind. So we'll say I call this A, B. Okay, so the A is going to be the point that is going to decide whether we're going to round up, whether we're going to leave it alone. Okay, now when we're doing rounding, rounding is, do you guys learn how to round when you guys were in school? Okay, so it's going to be a little bit different than when you're in school. Okay, just a little bit. If it's greater than 5, we round up. Okay, if it's less than 5, we leave it alone. If the number that we're looking at is exactly 5 and there's no numbers following it, then we leave it alone. If the number that we're looking at is 5 and there's numbers following it, then we round up. Okay. Have you guys ever been on a teeter-totter? You know what a teeter-totter is? You know, it goes back and forth like that, right? So the way I look at it is 5 is that even point, right? If it's exactly 5, it's that even point. So in that case, we're going to leave it alone. We're not going to round it. Okay. Now, if you just put a little grain of dust on it, right, it pushes it up. So then that means we're going to round it up. So if you have numbers following that 5, we're always going to push it up. Okay. So let's work this out here. So we're going to be using A as our determining point. Okay, so go ahead and add it up. So that's 0, 6, 3, 2, 3. Okay, so we're going to take a look at that 3 and decide, are we going to round this 2 to a 3, or are we going to leave it as a 2? Is 3 greater than 5? No? Okay, so then our answer is going to be 32,000. Okay. Piece of cake? Okay, so let's do the next one. Okay, so where does significant ends for that first number? At the end. So we're looking where significant ends, right? So we know that the first part isn't significant, so we have to go to the end of it to determine. Okay. Yep, after the second one. Okay. And then that's the same case for the next one. It'll be after the 1, right? Here, the third number, where does significant end? After the second one, right? And then the last number, significant ends okay. Okay, so which line are we going to use? Yes. Why is this one cut right there? The green one represents this last one, so it'll be after the 3. So this is for this number right here. Because these are significant. These zeros, they're captive. That's right. So they're going to be significant. Yeah, so you're going to have to go to the very end. And then this one ends right here at the reddish pinkish. Okay? Because it's at the very end of that number. Okay? Okay, so then A, B, or C, where am I going to draw my line at? A. Okay? Oh, it's not letting me erase here. Okay, so go ahead and add it up. 1, 5. Okay, there's a 1 there. Sorry. Okay, so I'm going to look at this 5. That 5 right there. So it's 5. Am I going to round up? Okay, I'm going to round up because there's numbers. That is correct. So my answer is going to be 1.017. The total of 466. Okay. Now subtraction works exactly the same way. So where am I going to draw the line at for the first number? After the 2. Okay. And the second number? After the 2. Okay. Okay. So then we subtract. Which one are we going to use? We're going to use the red line or the green line? So the green. It's going to be the red because it's always going to be the one that's farthest to the left. Okay, so let's go ahead and add up or subtract. 0. That's 2. 1. 8. Okay. So am I gonna round it? What's gonna be my value? What's gonna be my answer? 8,000. That is correct. Okay. This last one. Where am I going to draw the line? It'll be after the 3, right? Okay. And then the second one? After the 1? The second one? Okay. Okay. So am I going to use the red or the blue line? Okay. Okay, so let's go ahead and add it or subtract it. I brought my mouse and I'm not even using it. Okay, so then what am I going to use to round? 3. So our answer is going to be Okay. Questions? Concerns? Okay, good. Yes. Let's see. Okay, so let's talk about multiplication and division. Multiplication and division is a lot easier. So when we're doing multiplication and division, all we need to do is find the one that has the lowest number of significant figures, and that's going to decide our significant figures. So here, the very first problem, which one has the least amount of significant figures? The first one. And how many sig figs does it have? It has one sig fig, okay? Because we know these leading zeros don't count for sig figs. So, okay, so when we do the math, our answer is going to be 0. Let's see. Oops, actually, no, it isn't. Lion there. Oops, wrong race. It's going to equal 2.02. Okay, and if we do our sig figs, our answer is going to have only one significant figure, so my answer should just be 2. Okay, what about here? The second problem is division. Behaves the same way. Which one has the least number of sig figs? 10 has 3, so it's okay. So this guy has 3, this guy has 4. So our answer should have 3 sig figs. Okay, so if we do the math, this is going to be 2, 3, 1, 5, 0. Okay. So how many sig figs should I have? Okay, so my answer should be 230. Or is it 2? Are you sure? 231 or 232? Okay, it's a 5, right? What is the rule about the 5? 5 is perfect. Do we have a little more over to push it up? No, we don't. So we leave it at 231. 0, 0. So 23,100.
So whenever it's division, we leave it as it is if it's 5.
So if it's 5 and there's no numbers following that 5, we leave it as it is. So if we're using the 5 to determine whether we round up, if there's no numbers following that 5, so this has a 0 behind it instead of a 1,
Yeah.
then we leave it as it is. If there was a 1 here, then we would round it up.
Okay. So if it was a 4 and not a 5, it'd still be the same number we got.
Yep. If it was a 4, it would be 2, 3, 1, 0. Yeah. If there wasn't a 5 there, that was a 4. Yes.
Got it.
Okay. Piece of cake. Good. Okay. Let's move forward. Maybe. Okay. So also occasionally you'll see plus or minus. So when we use that plus or minus also means that uncertainty, right? So if we had a number that is between 0.6 and 0.7, then depending on the stick that we're using, the yardstick that we're using, this value could be either plus or minus 0.1 of a meter stick, right? So then we could sit there and say 0.6 plus or minus 0.1 meters. So that also shows us that uncertainty. But if we're able to get a little more exact, then we can go down and get a little more accurate, and it becomes less uncertain. Okay. Okay. So how many sig figs? 3 in the first one. Okay. What about the second one? 2 sig figs. Okay. Piece of cake? Okay, we've already talked about rounding. Are you guys feeling confident? Okay, so let's test this out. A student weighs a beaker and 4 different chemicals using different balances. The individual masses and their sums are beaker, 319.5 grams. Chemical A, 20.460 grams. Chemical B, 0.0639 grams. Chemical C, 45.645 grams. Chemical D, 4.173 grams. The total is 389.8389 grams. So, what is going to be our final answer using significant figures? What are we going to do first?
Use the 389.
Line it up. Okay, so we got it lined up. What are we going to do next? What was that? So we're going to draw our lines. Okay, for the first number, 319.5, where does significance stop? After the 5. Okay. What about the next number? After the 6. What about the next number? After the 9? Okay, and then the last 2 are going to be the same. Okay, so are we going to use A, B, C, or D? The red line, the yellow line, blue line, or the okay. I know my line is a little wiggly. I haven't been drinking really. So. Yeah, exactly. Not yet. Wait till I start grading your labs. Okay. That's usually not what that means. So I'm a nice drunk. I'm a social drunk when I'm drinking outside, but when I'm grading, I get a mean drunk, you know. Yeah, so.
What's your go-to liquor?
What was that?
What's your go-to liquor?
My go-to liquor? It depends on the day. I like whiskeys, you know, but it just depends. I have a nice Japanese whiskey at home, right? And no, I don't worry. I can get, you know, I can do, what is it? Dog Yard, and with the different flavors and stuff like that. I can do some JD. You know, we can go all levels of JD. So, yeah. It just depends on the mood, you know. Okay. Okay, so we draw a line there. Now, we already have the value. So if we have the value, we're going to be using which number to round? The 3. So the 3 is a 3. So are we going to round up or leave it alone? We're going to leave it alone, which is what we did here. I got carried away and I put the answer. Okay. Piece of cake, not too hard. Okay, good. Let's keep going. Okay, so we've already talked about the rules for multiplication and division. So here's the example. If the mass of 1.00 liters of gas is 1.436 grams, what is the mass of 0.0573 liters of gas? Okay, so what is my given? Okay, so my 0.0573 liters is my given. So then what is my equivalencies? Okay, so who's going to go on top and who's going to go on bottom?
1.4 on
Okay.
top.
That's right, 1.43 is going to be on top. And you guys said 1.000 liters on the bottom. Okay, so liters are going to cancel out. And we're going to be left with just grams. Okay, what did you guys get? So I get 0.0828. And that's grams. Sorry for running out of room. Okay, so how many sig figs should I have? I heard somebody say it over here. 3 sig figs. So my answer should be 0.0823. That's good. Okay, questions? You good, Brandon? Okay. Okay. Let's see. What can I clear? Okay. So we've already talked about the metric system. We've also talked about the US system or the empirical system, United States customary system. So 1 inch is going to equal approximately 2.54 centimeters. Thank you. And the mass is, for mass, 1 pound is going to equal approximately 453.59237 grams. And for volume, 1 gallon is going to equal 3.785411784 liters. So, do I expect you guys to remember that? No, I don't. Right. So, I have conversion tables in your packet that you guys can use on your exam. I know, I'm so generous. Okay. Okay, and you guys also know 1 foot equals 12 inches, 1 yard equals 3 feet, 1 mile equals 5,280 feet, and 1 pound equals 16 ounces, 1 quart equals 32 fluid ounces, 1 gallon equals 4 quarts. So, using all that information, a soft drink manufacturer is converting from USCS units to metric units. If the quart bottle initially is to remain same volume, what number of milliliters should be printed on the label? What's my given? 1 quart. Okay. So what are some of my units that I can use? So we could go 1 gallon, 4 quarts. So that changes my quarts to gallons. Okay. What else can I use? So 3.785 liters equals 1 gallon. So then gallons cancel out. So 1 liter, 1,000 milliliters. Liters cancel out. And then we're left with milliliters. So yeah, 946 point something. So if we started off with 1 quart, how many sig figs should we end up with? 1. So if we're paying attention to sig figs, our answer would be, okay. Questions? Good. Let's keep moving. You guys are doing great. Okay, so temperature. We've already kind of talked about temperature, right? So to convert from Fahrenheit to Celsius, we basically use this equation. Temperature in Fahrenheit minus 32 divided by 1.8. Now, if I want to go from Celsius to Fahrenheit, then I need to rearrange my equation using algebra. So temperature in Fahrenheit is going to equal to 1.8 times temperature in Celsius plus 32. Okay. if your body temperature is 98.6 degrees Fahrenheit, 6 degrees Fahrenheit, what is it going to be in Celsius? I heard somebody say it already. 37. How did you know that? What was that? You just did your work? Awesome. Well, you're quick. It also helped that we did it last week, right? See, that's my test there. So the answer is 37. So if we plug that in, you should end up with 37 degrees Celsius. Okay. So if water boils at 210 degrees Fahrenheit, what is that in Celsius? It's 100 degrees Celsius. Okay. Questions? Concerns? Cash? Okay. Absolute zero. What is absolutely zero again? Say it again. Okay, so no movement. It's the point of no movement. How do we calculate what is the absolute zero scale? Kelvin. Okay. God, you guys did pay attention. Oh my God, I must have a fever or something. What was that? Let me go get tested. Yeah. Okay, so we know how we convert Celsius to Kelvin, right? We add 273.15, and that'll change that to Kelvin. Okay. This here just basically shows you the equivalencies of the scales and how they kind of work. And let's convert 288 Kelvin to Fahrenheit. Can you do me a favor? Can you send the paper around so I can see who else here? It's census, so I have to take the census roll. There's blanks in there. Yep. Thank you. Just name. Okay, so what am I going to do? First step. Change it to Celsius. How do I change that to Celsius? You said, did you say divide or subtract? Subtract. Okay. Yeah, I thought you said divide. Yeah, that doesn't work. So we're going to subtract 273. So that gives me 15 degrees Celsius. Okay, so we have 15 degrees Celsius. How do I get that to Fahrenheit? Okay, how do I do that? Are you sure? Okay, so if you guys remember, we had that TF is going to equal 1.8 times TC plus 32. Also, if you look in your packet, there's that Army conversion. In that third column, there's temperature scales right there, and equations down there at the bottom. Okay. What did you guys get? So we plug it in. So 15, 1.8 times 15 plus 32 should be 59. Piece of cake?
How do we get the 1.8 again? I lost it.
The 1.8 is given to us in the equation. So this is just the conversion equation. Which is also the same thing as 9/2. Normally that's what you see. Okay. Okay, you guys ready? Or not 9/2, 9/5, not 9/2. Okay, clear. Okay, so what I'd like you guys to do is to fill in the table. Calculations to fill in the table. Okay, so for the very first Fahrenheit, that first blank, what did you guys get? -13? You got -13? Okay. Okay. That bottom one for Fahrenheit, what did you guys get?
105. Wait. 190.
Okay. What about the Celsius? Okay, the second. 41. Yeah, the one in the middle. And the bottom? Okay, for Kelvin? And the last one was what? Do you guys agree? Everybody agree? Any questions? Yes, ma'am. Yeah, so, and then, because we had a question about rounding, right? So when we're doing that rounding, if it's perfect, we shouldn't round up. And so unfortunately, these were all rounded up because it was like 0.5 for each one of them, or something, like two of them were 0.5. They technically should have been left alone. So you're right on that one. Okay. Okay, so last week we talked about directly proportional. When something is directly proportional. As this goes up, this is going up as well too, right? So we're going to be talking about density. Now, density is, there's a relationship between volume and mass. So volume and mass are proportional to each other. They're directly proportional to each other. As mass goes up, the volume has to go up. Okay, that kind of makes sense. The more of something you have in terms of the volume, it's going to get heavier, right? So what allows that to be equal, mass equal to the volume, is using a constant. Density is a constant. Okay, so the density of water, you want to remember this, is going to be 1.0 grams per milliliter. Okay, so if I have 50 grams of water, how many milliliters will I have of water? 50. If I have 100 grams of water, how many milliliters of water do I have? 100. It goes up directly proportional. Okay, So density is going to equal mass over volume. Okay. As I said, density is going to be a constant at given temperatures. Okay, because it's dependent on temperature. Okay. So we often will express density in grams per milliliter or grams per cubic centimeters, or occasionally we'll get it in grams per liters when we're talking about gases. Okay, so what happens if we take ice and we put it in water? Okay, that's true, it melts, but before it melts, it floats. Why does it float? Because the density of ice is less than water. Okay. So this basically just shows us that, right? So if we put ice in water, it floats on the top. Now, if I take ethanol and I freeze ethanol completely, right? It doesn't float. It will actually sink to the bottom of ethanol. And that's because the density of ethanol, the solid, is heavier than that of ethanol, the liquid. The reason why is, we take a look here. In the case of water, we have these nice little structures, right? It's very organized. There also leaves these little gaps where air bubbles could actually fit in there, right? So that allows it to be less dense because it's so organized than when it's water, where it's all randomly connected, interacting, okay? So these are some densities of common things that we come across. So why does a piece of wood float on water? Because it's less dense, right? So its density is less. Lumber, 0.5, water, 1.0. Why does it that a glass will sink to the bottom of the pool? Because it's more dense, right? Okay. Piece of cake, not a hard concept. The mass of a 50.00 milliliter sample of methanol is 39.59 grams. Determine the density of methanol. Okay, so what are we going to do? We're going to divide mass over volume because we know that density equals mass over volume. Okay, so that's 39.59 grams per 50 mils. How many sig figs should I have? One sig fig, are you sure? 4. Okay. Questions? Concerns? Kool-Aid? Okay. We're in the home stretch now. Oh, wait, one more question and then we can high five. Okay, so the density of a certain machine oil is 0.910 grams per milliliter. Find the volume occupied by 196 grams of that oil. Okay, what's going to be used as my conversion factor? Okay, so grams are going to cancel out. And we're going to be left with milliliters. What did you guys end up with? Okay, how many sig figs should I have? 3 sig figs, so 215 works because our number following that would be a 3. I do that, so 8, 4. So the answer is 215. Okay. Questions? Concerns? Cash? Kool-Aid? Wow, this went very smooth. Or food, yeah. Oh, that's even better. Okay, so then I will see you guys on those in Coalinga. I will see you guys on Thursday for lab. Those at Harnell, I will see you guys on Friday for lab. Okay.